Okay. All right, setting you guys up right over here. I got to do a lot of housekeeping today because I have just let my work table go completely. I've been working since I was fixing or fixing up Mr. Never Could Figure It Out's carburetor, and after that I had to build a new carburetor for myself, which I did. And then I had to get rid of a bunch of parts I didn't need. So then now I've got a bunch of main bodies and bolts and stuff that really don't need to be here. So I'm going to be up a little bit. Something I should be doing more often. I've just been really busy. I haven't had a chance to really do much of anything. Like these main bodies don't need to be here. I use them a lot for like demonstration purposes when I'm doing videos, but I'm not planning on building any of these right now. Except maybe this one. This one is on my list of things to do. So I've just got, this one's 575 I don't shut up about. It's one of my favorite carburetors. And I actually, this is a secondary plate, 64, that I modified to install on the secondary side without the metering block, so to a 4160, converting it back down, and I was actually planning to plug these little orifices that are for the jets and then drill right here so I can install traditional jets right there is where they would be. So I'm going to have a video on that where I actually modify these for them to accept jets, but that's in the week I should have that good to go. Let's see. Where does these things go? Right here. I've just got a mess all over the place. I've got things done today. It's just been one of those days where I just go and take care of a lot of house chores that I've been putting off for a while. So it's just one of those things that needs to get done, but I never do. A lot of 67s here. So yeah, just basically doing a lot of cleanup. If some of you guys start asking questions, I'll go ahead and answer them. But for the most part, it's just gonna be a lot of cleanup here. I do have a lot of secondary plates I need to modify. So actually, I might do that right. Oh, what the heck? Oh wait, no, never mind. Never mind. Ooh, this is an 81. This is an 81. 84. 67. Why are these here? There we go. 67. A lighter 67. So I had this issue where I installed one of these, a 64, to replace the 67 that was in the carburetor that I sent. And I never really thought to why they're like different shapes. And then I realized that they're a different shape because the 64 has the idle transition together to the main well, and this one has them separate. So this is for a carburetor that's only for two-corner idle, and then this one, or I don't know actually. I don't know. I don't know why these systems are separate. Like for example, this one's upside down. Well, actually, they're both supposed to be like this. So this is like set up like this, and the difference between this one and this one is that this one has like this thing for the idle, which is weird. So anyway, I installed the wrong I installed the wrong metering plate, and I ended up, I had a rich condition that I really could not figure out where it was coming from. And it turns out that when you install them, if you install this one on your main body, you've got the idle feeds right here, the transition idle feeds, and then if you overlay this one, the transition doesn't pass down through here, and in fact, this corner will be exposed, and so the carburetor will start drinking raw fuel, avoiding the emulsion system altogether, and it'll just start pulling fuel from the bowl, and it's just a crazy rich condition. It took me a little while to realize what was going on, but after I took it apart and I realized, switched over to the 67, I was good to go. But then I couldn't jet down, so what I'm gonna do actually is I want to go ahead and block these off. I'm gonna go ahead and drill these out, and then I'm going to block them with I bought some set screws for this. I think they're over here. Yeah. So I bought some super tiny, I think they're I want to say they're 624 is the thread pitch. So you've got these super tiny 624 set screws, and these will end up sitting right there. I don't know if you guys can see. They're gonna be sitting right there. So this one's gonna block one. This one's gonna another one's gonna block the other one, and then from the inside, I'm gonna find. Well, I'm gonna see if I should drill here, or if I have to drill more towards the bottom. I'm gonna do a little bit more research on where I'm supposed to actually drill these out, and then it'll go all the way through, and then you'll be able to run regular jets here, and so your main well is gonna be fed by the jets instead of by the fixed orifices on the bottom, and then your 4160 carburetor will essentially become a 4150, but it'll be a single feed 4160, which is, I like them. I like 4160s. They're really light. They're easy to mess with, and I do like the way they perform. They're just compact, less parts. So eventually, I'm gonna get around to doing this. I'm not gonna do it because I do need to focus on cleaning up a little bit, and then I pulled these O-rings out, and then this is what I ended up using. Let's see if R08. Let's see. So this is a R03 5. So this is a metric 5 by 2 mil. 5 mil by 2 mil is what the section inner diameter. 5 mil by 2 mil is the size of the O-rings that I actually used to fix the what do you call that thing? The needle and seat. The recent video that I put up. Yeah, 5 mil by 2. I gotta remember that. 5 mil inside diameter, 2 mil thick. So this guy, I'm not gonna use that right now. Metering blocks back. Some of these, secondary metering block. I'll throw these over here. Don't really need them here right now. There are most of these are for demonstration. I've been messing with stock metering blocks a lot. Really, I haven't been really messing with aftermarket meters. A lot of times the OEM ones, they will, their orifices will be too small, which is great because when the orifices are too small on the OEM metering blocks, then you can just drill them out to the size that you need. Essentially, it does what an adjustable metering block does. So it's really not like someone wanting to mess with their carburetors. They really don't need adjustable metering blocks. They know how to measure and how to work on their stock metering blocks. So this one's a 6.5. I might put that one aside. Does one still work? No. This one also 6.5. Yeah, see, I've just been accumulating all these metering blocks over here for some reason. I think every time I do a live stream or every time I do a video, I go grab another one off the shelf. And I really should stop doing that because I have so many here taking up space. Look at all these metering blocks. How many has that been? Like 15 metering blocks already? Oh, this one I said I was going to mess with it. So, a quick tour, I guess. Since you guys are here, I'm going to be showing you guys all the carbs I have. I hope the picture doesn't... I've got basically where I've been working right here. And then here's where I've accumulated a bunch of main bodies. And I've got some more main bodies up there. Setting that down. Another main body. So some of these are 600s. Some of these are 650s. Some of these are 670s. And then all my 750s I got rid of. And then I have one 850, which is that black one right there. That one's an 850. And then I've got a bunch of Holley float bowls. My MSD harness from my old video. Some hardware on top. Some, what do you call those things? Base plates. Here's another one of these. I'm gonna find a place for them. And then I've got a bunch of metering blocks over here. So you guys can see, instead of looking for the metering blocks I already had, I just end up grabbing another one off the shelf. And I end up having a bunch of them. Like, look, here's another one. I just leave them here. So since I already finished the carburetor I was working on, I don't need any of those parts here. So I gotta start getting rid of all this stuff. Like this float bowl I don't need right here because I already finished the carburetor. This float bowl I don't need right here. So the next project's gonna be that 575 that I'm working on. Just because the 750 that I just put on my truck, it's a little big for what I need it for. So I do really want to go a little bit smaller. I ran it jetting on the 750 for the 5.3 LS was actually very similar to the jetting that I had on the 625 that I used to run on it before. So we're looking at 70 in the main jets, and I believe I have 60, what do I have? 65 or 66 in the secondaries, I believe. So I'm going to need to, I'm basically going to need to downgrade to like a 650 or a 625, and then hopefully the jetting stays about the same, which means it's pulling about the same amount of power. Jetting is decided in relation to like your base plate. So your base plate determines response, but your Venturi determines maximum airflow. So what that means is if you have a 600 and you put a 650 base plate, you're going to introduce more air earlier than you would with a 600 base plate because the diameter is bigger. As you accelerate, you expose more of the circle, and a 650 circle is bigger than a 600 circle. So if you raise it, let's say a quarter of an inch on a 650 is more than a quarter inch on a 600, which is why they say that a 650 will waste more gas than a 600, because you tend to overcompensate the throttle just a little bit much. And so then the difference between the 650 and the 750 is the throttle bore, the Venturi, which, like I said, is decides maximum airflow. Really, the CFM, the maximum CFM. So, which is why the difference between a 600 and 650 is only 50 CFM, because of the way the Venturi is set up. The Venturi is the same size on a 650 and a 600, but the 650 and a 750 have two different Venturis. The 750 obviously is a little bigger. So on my Demon 625, it has a 650 size Venturi and a 750 size throttle bore, which is essentially a 650, 750 throttle plate, the same. So it's really just a 650, but it had annular boosters in the secondaries, and it had downlink boosters in the primaries. Plus, it had the main body was like where it was all chamfered, very wide opening, a lot of airflow was allowed in here. So although it was rated at 625, it wanted jetting like a 750, which tells me that it's flowing significantly more air than a standard 650 would. Really, that's how you can determine how much of a carburetor you're using up, is by the amount of jetting that you're introducing. So if you put a 600 and it keeps wanting more and more and more and more jet, it means your engine wants more and more and more, is sucking in more air than it was designed for. Like, let's say you get a 600 and it came with 66 primaries, 66 secondaries, and it wants 70s. That means your engine is really, really sucking on those primaries and the secondaries. Let's say you jet up as you're driving. It wants 70s in the main, but it wants 65s in the secondaries. If it only wants 65 in the secondaries, it means that you're using up a lot of the primary. But as soon as you go into the secondaries, the carburetor is sufficiently big enough to feed the whole system. So as you, because you have to remember that these carburetors are square bore, so the front and the back are the same size. So in reality, when you're racing, let's say, you want to have, if it's a professional race, you want to have the front and the rear jets pretty much square, even, because you're at wide open throttle. You want distribution to be 100% even on the front banks and the back banks, left and right. So you want all of it to be even, so you go ahead and make the most amount of time. So then when you jet up, you're jetting all four corners at the same time, and you keep jetting up until the car doesn't get any faster. Then you try individual cylinder or individual corners. You jet up that one, then you jet up this one, then you jet up that one at a time, to see if it gets faster that way. And eventually, you're going to get to the point where the carburetor has reached its maximum jetting and its maximum airflow, and it does so at all four corners. If we translate that to, let's say, a street carburetor, where let's say your primaries are 65, your secondaries are 58, that means your carburetor is still, let's say, too big for your application. So let's say you put a mild cam in it, or let's say you could put a radical cam in it, let's say you put some long tube headers, you put a bigger intake on it, and you're going to notice that on not only is your primaries going to want more jets, but your secondaries are going to want more jets, because your engine is breathing easier through the entire power band. And in fact, I noticed that a lot of engines lack top end power. It doesn't matter if it's an LS, a small block Chevy, small block Ford, a Mopar. I've noticed that every single stock camshaft really suffers in the RPMs, and a lot of that has to do with the lobe separation angle, as well as the duration that they use to allow the engines to comply to smog laws and emissions. So any 318, any 302, any 327, any 350, 351, any one of those stock engines pretty much needs a cam. It doesn't matter what cam it is, as long as it's a performance-oriented cam. It can be a stage 1, it could be a truck cam. Any cam is going to unlock the top end So you really want to, if you're running a stock engine, stock heads, stock piston, stock intake, the best modification you can do is a camshaft, because a camshaft on any engine, any stock engine, is going to go ahead and wake it up. And so the jetting changes significantly between a stock engine and a modified engine, because on a stock engine, like I said, we don't have a lot of top end. We don't have a lot of top end airflow going on. So your jetting is going to be like 68 in the front and 65 in the back, or 62 in the back. But as soon as you put that cam in, maybe instead of 68 in the front, it wants 70. And maybe instead of 65 in the back, now it wants 68. And it'll just keep going up and up and up. The more compression you have, the more timing you have, the better heads you have, the better intake you have, the better you allow the engine to breathe, the more jetting the carburetor is going to need, because you're allowing more air to enter and more air that's exiting. So whatever exits has to come in. So even something as simple as long tube headers will make, or will allow your engine to breathe significantly better. I ran this test between shorty headers and long tube headers. So pretty much back to back, I had the shorty, and my engine was jet at 66 in the primary and 58 in the secondaries. And then I switched over to long tube headers, and my secondaries went up to 64, from 58 to 64, and my primaries went from 66 to 68. So what that tells me is that the old shorties were actually restricting airflow, and when I switched over to long tube headers, that airflow was restricted, and I was able to exit more exhaust out. Not only did I exit it out, but then because I exited more exhaust, I was able to bring more intake air, which allowed the engine to breathe better, which allowed it to burn more fuel, and then eventually more power. So the flip side of that is, if you don't want to waste more gas, if you want to keep it economical, then you should probably keep it all restricted, because as you modify it, put better heads, etc., not only are you adding an economical cost to it, you're also allowing it to make more power, which means it burns more fuel. But if, let's say, you're running like a slant 6 or a 302 or a 289, something really small, really mild, you're really not using it for, I mean, you could be using it for MPG, but a lot of times you really want to hot rod those engines, because they really just fall on their face if you just leave them in stock form. I mean, 150 horsepower is not going to be impressing anybody. But if you've got maybe 250 horsepower, 300 horsepower, 350 horsepower, that's something you're probably going to feel. But especially when you're messing with carburetors, a lot of people, although they do worry, like MPG's on the back of their mind, always on the back of their mind. But the seat of the pants feel is really what they're looking for, especially carb guys. That's why they look into getting rid of every single bit of hesitation right off the line. They want clean starts, good throttle response. They want to make sure their top end is not too rich, not too lean, pretty much perfect. That's why they're always checking their spark plugs. Not because they want to maintain good MPG, but because they really want to keep the engine running as optimal as it can. Ironically, it's not going to run as optimal on a carburetor than it would EFI, but if we're talking specifically racing and hot rodding, then yeah, a carburetor does every bit as good as any kind of EFI application, especially on more classic engines like the 302, the 381, the small block Chevys in general. Those engines, although people love those engines, don't get me wrong. I've had plenty of small block Chevys and small block Fords, and then right now I have a ton of small block Mopars. But a lot of people look at those engines really with rose-colored glasses. They're not that great. In stock form, they are actually really, really bad. It doesn't matter if it's a high performance 327 or a Vortec 350. Like, they're not their head design, their compression ratio. They're just not very good engines. So when you move up to, let's say, the Gen 3 Hemi, you move up to the LS, even the modular 4.6, 5.4, those engines outperform the old engines by leaps and bounds. And so a lot of that has to do with Richard Holdner goes through this a lot, but a lot of it has to go through intake manifold design, which is why in the old days, the old small blocks, when you took off the EFI and you installed the carburetor, you almost always made more power. Always made more power, because the old intakes had very little design elements incorporated in it to produce torque, to produce horsepower. They kind of just made the intake for the engine and just let it go. So when you ripped all that stuff off and you put like a Super Victor on it, yeah, it's going to make 20, 30 more horsepower when compared to the stock EFI, but it's not the carburetor doing it. It's the intake manifold design that's doing it, if that makes sense for everybody. So, like I said, as you keep hopping up your engine and allowing it to breathe more and more and more and more, and increasing the duration and getting it more and more radical, you're going to start stepping up on that secondary jetting. So as you guys all know, like big intake runners, big intake runners, short runner intakes, those are all for really radical camshaft. Those are all for really high RPM, like racing, right? So when you install, let's say, all three of those components, you end up losing a lot of that low-end torque. So on the dyno graphs, I know basically everyone in this chat has seen Richard Holdner. But as you guys watch his stuff, when he puts the more radical stuff on it, torque tends to go down. So what that does to the jetting is anything on the low RPM torque will be decided by the primary jet. Anything in the high RPM will be decided by the secondary jet, only on street carbs, because like I said before, race carbs perform a little bit differently. So the more radical you go on your cam selection and intake, etc., the less jetting you're going to need in the primaries, because the engines don't breathe as well in the primaries. But in the secondaries, they start screaming. So most of the jetting, you'll reach a plateau where you reach maximum jetting on the primaries, and then your rear jetting's going to go up. And then as soon as you pass the primary jet with the secondary jet, you know that the carburetor is now too small, because the carburetor is pulling more air through the secondaries than it was through the primaries. So in reality, in a perfect world, it should be running at wide open throttle. All four corners should be running exactly the same. But if we're talking street cars, low RPM characteristics are a little bit different from high RPM characteristics. And fuel distribution doesn't much when you're thinking about drivability, except in the terms of a single plane versus dual plane, in which it does, because you do want the companion runners running correctly, and you do with the four hole spacer. So I've been talking a lot. I'm out of breath. I am out of breath. Let's see. Weird. I think I might be lagging a little bit. Let's see. What's going on here? Somebody tell me. Yeah, that's a brief description of jetting. Eventually, I'm going to have a full-on video describing the jetting on a carburetor and how you should go about you're going to be able to figure that out on your own as soon as you slap a wideband on it and you go to town with that, because a wideband is really your best bet, your best telescope inside into these carburetors. Because if you don't know where to look at and you don't know what circuit to narrow down, you're gonna be you're gonna be trying to do a bunch of modifications that aren't really necessary, because you think you've narrowed down the problem. So then you go to all the effort of working on these on your carburetor, maybe changing the power valve or changing the jetting, only to realize that none of that mattered, and it was actually in the transition, which actually that way, because I've noticed it very often that a lot of the problems, a lot of carburetor problems stem from the transition. Very little of it actually comes from the jetting, but I have seen the jetting be too rich, especially when the carburetor isn't sized correctly for the application. I've seen the jetting be a little bit off, but if you size a carburetor appropriately, you shouldn't have too many issues. But for example, I talk about this engine a lot, but my friend has or had, because he blew it up, a small block Chevy 383, and he bought, according to the engine builder, they said the best engine or the best carburetor for that setup was a here's another 73. The best engine for the small block, or the best carburetor for the small block Chevy, a 383, was, or a mild 383, I think it was rated at 425 horse, 450 horse. The best carburetor for that particular application was a Holley 670 Street Avenger. So then he bought the Street Avenger and he installed it, and it was just running really bad. It was hesitating. It didn't have that oomph. Once he got in the wide open throttle, it cleaned up around 3,000 or 4,000 RPM, and then all the rest of it ran really good. But in the low RPMs, it was hesitating and had a lot of issues. So he brought it over to me, and I had told him before to get himself a wideband so he can go ahead and do the tuning on it, and then if he ever modifies it, he can it, because it just saves you so much of a headache. They're a little expensive, $180 for the average AEM wideband, but I mean, it's worth it. It's worth every penny. I tell this to every person who messes with carburetors. Get yourself a wideband, because it will pay for itself. If you can prevent your engine from overfueling, you will save your engine, and the wideband will pay for itself immediately. If you are noticing that you're wasting too much gas and you can jet down one size, eventually the saved fuel will pay for not only will the engine run better, but it'll pay for the wideband on its own. But anyway, so he didn't get it. He didn't get the wideband, and what ended up happening was he brought it to me, and I wasn't going to install my wideband on it, so we pretty much caveman the whole thing. First thing I did, infamous Nova, what's going on? Good to see you, buddy. You finally got your thing running? You only had like 2 things left to do. So basically, he brought it to me, and I took it apart, and I took his metering block apart, and I started doing some measuring. And on his metering block, I measured that the IFRs were at 28. I saw that his main jets were at 68, and his secondary jets were, I believe, at 72, 73. And what I did was I grabbed one of my extra metering blocks. You gotta free up. You gotta do it, man. You gotta eventually, sometime in the next year or 2, you gotta finish your car. So anyway, I grabbed one of my extra metering blocks, and I set it up exactly how the stock metering block was on a 670. So then what I did was I set it up, and then I enlarged the the IFRs, I increased it from 28 to 32, or not 32. I went from 38 to 30, and then that was the only change that we did, and then we put it back on his car and ran it and started driving, and most of the hesitation went away almost immediately. We came back, and then I went from 30 to 32, and then we drove it again, and then it got way better. So then we go ahead and take my metering block off and put his metering block back on, and drilled it out to 32. So then now his has the 32 in the 32 IFR, but he still has the 68 jets. So then I had him drive. We put in a fresh spark plug, just one on one of the corner cylinders, and we went into the main jets and we started driving. We drove a couple miles. We pulled over. We pulled the spark plug, and it was really white. It wasn't brown at all. It was really white. So we drove it back to my place, and I jetted it up two sizes. Actually, I think he had 67s, and I jetted it up two sizes. We went to 69s. And then we put a fresh spark plug in the same hole. We drove it again for a couple miles in the main jets, and then we pulled over and then looked at it again, and now it was a very light brown, but it was nice, but it was a very light brown. So we jetted up from 69 to 70, and then drove a couple miles, and then it was a nice solid light brown, and that's where we left it. The only issue after that was when he suddenly stomped on it. He still had a hesitation there, but it wasn't. It had more to do with the way his transmission was set up than it was with the actual carburetor. Can you explain the base plate and vacuum, how it all works? What exactly on the base plate and vacuum do you mean? Like, yeah, clarify on your question, Nova. I'm more than happy to explain it, but you gotta clarify your question a little bit. So anyway, on the automatics, when you stomp on it, you have to wait for the torque converter to wind up, pressure to build up, and then it'll go. You always have that little bit of a lag, but he wanted to minimize it as much as possible, so a lot of it was in the throttle cable tuning, that it was sensitive enough, and when he stomped on it, the transmission would go in between shifts, and it would lag, and then it would hit the shift, and then it would go, but it wasn't. Okay, let's try this again. I just reset my connection. So let's try this out. Hopefully, I don't have any issues. It looks like it's actually. It looks like the link is back up. Okay. All right, Nova, are you in there? I'm about to answer your question. If not, you're gonna have to go through the entire live stream. The 30-minute mark is where I'm leaving off. So I guess he wanted to know how the port for the booster actually works, like the port. So a lot of these base plates, actually most of these plates, if not all of these base plates, they will have little passages, and each passage does something. So for example, if you look at these three, this one has three. This one has one passage that leads nowhere, and then you have this passage that leads to the throttle bore. So this passage will be manifold vacuum, because this one leads into the intake, and then this one that leads nowhere has a little orifice here, has a little hole that goes up. That's going to be for your ported vacuum. So this one picks it up from above the base plate. This other one picks it up from below the base plate. Other types of carburetors will only have the little one, which will be manifold vacuum, and then the other little one will be on the metering block. That one's going to be ported vacuum. And then some will have no little ones on the bottom, and then some will have just the one on the. but most all of them have either one or two, either one or two big ports. So the smog era, a lot of smog era cars had two, one for the PCV system, and then one for your brakes. If the intake manifold didn't already have a port set up for it, it would have two. If the intake manifold did have a provision for, let's say, your booster or whatever, then the carburetor will only have one. But most stock Holleys have at least one. So if you buy an aftermarket base plate like this one, this is an aftermarket base plate. This one has it's a billet aluminum base plate, but this one has a port that is plugged. This will be for your, and then has a little tiny port. And if you look in here, it also feeds to the same passage. So this is also, you have manifold vacuum, and then you have another manifold vacuum. And this one does not have any provision for a ported vacuum source. So you're going to get that off the metering block. And if you can't get that off the metering block, well, I mean, you always can. You just have to do a little bit of drilling. But you could always add the ported vacuum one if you really need it. So Nova's question was, how does that actually work? Where do the brakes get their vacuum from? So this whole system right now is upside down, obviously, because the carburetor is upside down. But so this thing's bolted onto your intake from the throttle bores to the intake. It's all open. As the engine turns on, the engine starts sucking in air. So under normal engine off conditions, we're under atmospheric pressure. So a carb spacer can do the same function. Yes, a carb spacer with a port drilled into it that you can like a PVC port or a what do you call it, MPT port to put in a like line or 5/16 line would do the exact same thing. As long as it's feeding out of manifold pressure, that would work for your brakes. So as the engine turns on, it starts pulling a vacuum inside the intake manifold, and it will not pull a vacuum on top of the throttle bores. The throttle bores, that's what's called ported vacuum, because it only activates when the ports are open. So anything from like your EGR valve would work off of ported vacuum. Your brakes would work off of manifold vacuum, because if you were to run your brakes off of ported vacuum, they would only work when the throttle is open. And since you need your brakes all the time, they have to be below the throttle plate, and that's why they call it manifold vacuum or absolute vacuum inside of the in the intake manifold. So if let's say you are running a stock engine, you're going to be pulling about 16, no, probably more, probably like 18 to 22 inches of vacuum at idle on a very stock or even, yeah, stock, maybe a little bit mild engine. You're still going to be pulling anywhere from 16 to 22 inches of vacuum, which is more than enough for your brakes to actually work. At wide open throttle, vacuum drops to zero, which is why your brakes don't work when, like, let's say you floor it and then you try to hit the brakes. Your brake pedal is going to be really hard because it doesn't have that help. Let's see, plan on doing a 5.3 swap on my El Camino this year. The only thing I'm still trying, hold on. The only thing I'm still trying to wrap my head around is the wiring. I want to keep the body harness, but run just basic switch setup for the fans, ignition, etc. I'll jump on to your question in a second, Tyler. Let me just finish up here. So anyway, as you put bigger duration camshafts, your vacuum will start dropping. If you get big enough, your vacuum will drop to a point where the vacuum inside the manifold isn't strong enough to help you pull on the booster to activate your brakes, which is when you'll have to switch either to a mechanical fuel vacuum pump that'll provide vacuum to your brakes, or you're going to need to switch over to an electric vacuum pump, or finally you might need to switch over to a hydro boost setup that runs it off of a drive, and then that'll provide the vacuum that you're lacking from your carburetor. But The basic thing is that the vacuum brakes need a full-time manifold source. It doesn't matter if it's from the intake, from the carb, spacer, or plate. As long as it's full manifold vacuum, it'll work. So it doesn't know where it's at as long as it's inside. It doesn't matter if it's only on one runner. It doesn't matter if it's on the plenum. It doesn't matter as long as it's full manifold vacuum and it's the right size. You want to use, I believe most brake systems are set up for 3/8, but as long as you have that, nothing else should really matter. So jumping over to the El Camino question. So if you're doing, let's see, you didn't mention if you're doing a carbureted swap or not. So I'm gonna assume you're doing an EFI swap. So if you're doing an EFI swap, the stock 411 PCM, oh, you're doing carbureted. Okay. So if you're doing a carbureted swap, it's actually really easy. So if you have enough room, let's see, El Camino, what year did you say the El Camino was? A lot of them, it doesn't say. Oh, it's 86. I'm not sure if the 86, I know the older ones have enough room for the mechanical fan. I don't know if the newer ones have room for the mechanical fan. But if the newer ones can run the mechanical fan, like if you have enough physically enough space, then I would definitely run the mechanical fan. It'll save you so much headache. If you don't have the space, then you're gonna switch over to electric fans. And since you're deleting the PCM, you're not gonna have the capability from the computer to power up your fans. But you could always buy. You can even get this at a parts store. I think it's Hayden. Hayden makes an electric fan controller that you can use. I think AEM has a fan controller. There's a bunch of different good companies that make fan controllers. Basically, they put in a little temperature sensor inside either one of the heads, or you can drill a port out on the water pump so you can get a temperature reading for your gauge. And then you can, or for the module, and then the module will actually decide when to turn on and off the fans to get them to cool down your engine. When it reaches a certain temperature, the module will turn it off, and when it reaches a certain temperature, it'll turn the fans off on all the time, because number one, you'll probably burn them out eventually, because I've done it before. I've had them wired up to an ignition switch. Yeah, ECM is gone. Rip that sucker. We all do that. All of us carbureted guys do that. The yeah, so if you wire up your fan to a relay and your ignition switch, what'll eventually happen is you're going to burn up the fan. Those fans are not designed to be on all the time. Plus, you're going to be overcooling your engine, and that's really not good for a carbureted setup. So if you're going to run electric fans, you are going to want to invest in a controller and a fan controller. It should be plug and play. For example, if it's an 86 and they're all mechanical gauges, so you can run the stock small block Chevy coolant temperature sensor from your old engine. You can use an adapter plug inside the heads. That'll feed temperature back into your stock gauge. I don't know if you have an alternator gauge, but if it's an alternator gauge, you can probably wire up direct. If it's an ammeter, you probably don't want to wire that up anyway. You're gonna have to find something else. Oil pressure sensor, same thing. You take off the stock LS oil pressure sensor that's on the back of the block on top. Put in an adapter plug, and you can run the stock small block Chevy oil pressure sensor right on top. No problems there. And then your fuel level, well, that's not controlled by the PCM. So really, all your gauges are super easy on these older vehicles. Are super easy to maintain. RPM should be really easy. That's the same that I did. I bought an adapter and used a rear passenger head, plugged my fan switch there. Yeah, see, infamous Nova, he's already done it. He's been working on this thing for like 2 years. Will changing the power valve in a Holley to a lower inch vacuum save gas in an 84 4C and still climb hills under heavy load, like 2 in? So power valve, let's see. I'm going to jump back to you, Tyler. Give me 1 second, then let me answer James's question real quick. So um, you're gonna need two things. One, you're gonna need to make sure you have a vacuum gauge hooked up on your engine, and second, you're gonna want a wideband. But if you don't have a wideband, you can do it without the wideband. If you install a lower inch vacuum power valve, your power valve is going to come in later. So if you take off the stock 6.5 that most Holleys have and you put in a 4.5, your power valve is not going to open until you reach 4.5 inches of vacuum. So I don't know how modified your 460 is, but if you drive around with the vacuum gauge, I started in 2020. If you drive around with a vacuum gauge and you go up like a very specific hill, let's say you say, okay, I want to make sure I can at least climb that hill. So you're going to go ahead and climb that hill as you are right now, and you're going to see your vacuum gauge. Driving normally, take a 7 at cruising. Oh, okay. You're having 7 inches at cruising. Wow, that's pretty bad. That's pretty bad. Um, but yeah, so you're gonna go up that hill. Make sure that as you're going up that hill, if you need to go power valve, you need to make sure that when you're driving up that hill, your vacuum is right exactly where your power valve is supposed to be, and just give yourself a little bit of room. So let's say you're going up the hill, a really steep hill with a 14 at idle. Okay, that's not bad. You got a pretty a decent cam in there. So when you're going up that hill, it's an RV. That makes a lot of sense. So as long as if you're at wide open throttle, then it doesn't matter what power valve you're in there. You're going to be at 0, right? As you're climbing up the hill. But if you're climbing up the hill and you're at 4 inches of vacuum, if you're at 2 inches of vacuum, you got to make sure the power valve is just above that. So if you're climbing up and you're at about 2 inches of vacuum, you want to get a 2.5. So on the flip side of that, if you're driving around and you go up a slightly not as heavy hill, but you're still hitting about 3.5, 4 inches of vacuum going up that other hill, you want to make sure that you're also not leaning out. So for example, for me, I drive a lot with trailers and stuff. So I actually went from a 6.5 to an 8.5. And here's something to think about. I know you don't have a wideband, so it's a little hard to know, but you can the power valve isn't really going to save you that much gas as is switching over your jetting. So if let's say you had a wideband on there and you are normally, you're at about 12 and a half to 1, which is a safe AFR, right? But that tells you that you can go up 2 or 3, or you can go down 2 or 3 jet sizes and still run fine. So you want to get your AFR as lean as possible, and then to make up for that under load, you want to bring up your power valve, if that makes sense. So, for example, if you're cruising at 7 inches of vacuum, and you're cruising at about 13 to 1, but you go up a hill and you start leaning out a little bit, and so you lean out to 13 and a half, 14 to 1, but you're still not in that power valve, you're still pretty safe. But if you lean out your jets to 14, you got to make sure that as soon as you're under that load, you're in the power valve. So that way you have enough fuel to prevent any kind of lean condition detonation, but you wanna be lean enough so that you're not wasting any kind of unnecessary fuel. So when you're thinking about MPG, it's a little bit different than when you're thinking about wide open throttle performance. Wide open throttle performance, you want to put a lower number power valve. If you're thinking about gas mileage, you want to out your main jets, but increase the number of the power valve. So if you get a chance, pull out your plugs, take a look at them. That'll give you a generalization of what it's burning right now. If it's a little dark and you can afford a set of jets, try to go 2 sizes down. If it's somewhat black, go 2 sizes down and either keep the power valve the same, or if you start noticing hesitation, get 1 or 2 numbers up and try it like that. If you're looking to save MPG, you're gonna have to play with it a little bit, but you're gonna notice a lot more fuel saved through jetting than you are from power valve. Hope that helps you out. let's see. I jumped over. Let's see. I skipped Tyler. Tack filter, like the distributor does. So the um, tack filter. I don't know. I know. I get it. Yeah, it's a balance that you really have to. You have to. It's not like a straight thing. Everybody's situation is different. You have an RV with a really big engine, so you're setting it up a little bit different than maybe someone that has a Miata with the 5.3 carbureted. So it's very different, and how you approach it and how you decide to go through it is case by case, basically. You're welcome, James. Any other questions for me? Um, so Tyler, the for when you switch over to carbureted LS, tack signal out of either the Daytona sensors, Smart Spark LS ignition box, or the MSD 6014, whichever box you decide to go with, both of them produce an HEI square wave. So I think in '86, I think HEI was stock. I know it was stock on the trucks. I don't know if it's stock on the cars. But if your stock tack is compatible with an HEI distributor, then it's gonna work with your ignition box, whichever one of the two that you decide to get. Both of those produce the exact same square wave. So if your setup right now works perfect on an HEI, it'll work perfect on the ignition box. But let's say you don't have an HEI and it runs off of something else, like let's say the coil wire or something, then you're going to have to make sure it works well on an HEI. And I'm sure there's a couple different write-ups, but when you're trying to get it working, and if it's not working immediately, look up your specific model and then add HEI, because whatever will fix an HEI on your model of car will allow you to fix the tack wire on either of the ignition boxes. So that's how I was able to figure mine out. When I installed the Toyota clutch on my 75 Dodge, I got all the sensors to work except for the tack, and then I had to modify the tack to work with an HEI signal, and then after I made it work with the HEI signal, which I had to add a resistor inside of the tack to actually make it work. But after that, I was able to just plug in directly from my ignition box to the Toyota tack, and it was working perfect. So now I have a working tack, and if I ever want to switch over to an aftermarket tack, I can just unplug the Toyota one, plug in the just a standard generic aftermarket tack that works off of HEI, and you should be good to go. A lot of aftermarket stuff is small block Chevy based. So anything that usually when I go through a modified application, I'll look, and a lot of times it's Delphi sensors, Delphi connectors, weather pack connectors, GM bar 1, 2, 3 bar map sensors, GM intake sensors. It's a lot of GM stuff. So especially in the electronics, although they don't openly state it, when you start looking at all the intricacies and you look at the square waves and stuff, you immediately realize that the electronics are based off of a GM platform. All this talk is making me remember I won't have a speedo. Well, I mean, there's pretty easy fixes to a speedometer. I'll jump into that in a second. Let's see. Yeah, I'm going 64 teams. It comes with the package I want. A 5.3 car package only because ATK is right here in Dallas and I can pick it right up. Use digital hub. I want ATK 5.3. It's a cell phone app. I love it. I don't know. I'm gonna have to look up what the ATK 5.3 car package is. If I had my computer turned on, I would just look it up right now. But if you want to tell me what it comes with, that'd be really cool. I think James is correct. You can even get like a little cheapo laptop, run the app off of that, and then you can stick it on your you can stick it on your dash. Another thing you can do is, like you said, you can use your cell phone, stick your cell phone on the dash, and then you can have that as well. But depending on the transmission, they make sensors that you can plug either into your rear diff, your output shaft, and then it'll convert that into a digital speedo. I use an old cell phone, yeah, like an old Android phone that you can get for $60, and then just hardwire the charger into your battery. A lot of those chargers you can just cut the wires out or plug it into like a USB device into your phone, into your car, like a USB port, and you can have it always charging. And then as soon as you turn it on, I mean the cell phone life should be able to survive. I mean, if it's hooked up directly to the battery, then it doesn't matter if you have the key on or key off. But yeah, that's probably the easiest way. James is right. I don't have a speedometer on my um, I don't have a speedometer on my truck either. I kind of just gauge it depending on what gear I'm in and what RPM. So when I'm driving on the freeway and stuff, I just try to match traffic. But if I know that I'm in fifth gear going over 3,000 RPMs, I know I'm going pretty fast. So then I try not to go over 3,000. That's kind of my personal limit when I'm driving around. But even on 456 gears and 35 size tires, 3,000 isn't that fast. It's like 75, 80 miles an hour. So, um, but yeah, speedometer isn't a lot of this LS stuff isn't very difficult. You can make it mirror off the windshield. Oh, I've seen that as well. Yeah, I've seen kind of like how the Camaros have the little HUD. Yeah, that's really cool. ATK 5.3 Holley dual intake. That's actually the one that I have. The 6014 and the Valley pan and timing cover and oil pan. Although the oil pan will probably be useless to me for a G body. So it comes with the engine as well, or the engine is separate, and then it'll just come with everything else. ATK. I wonder what ATK is. Okay, I'll check out DigiHub. I mean, your thing is I think yours is basically a race car. I everything out. Oh, it comes with the engine too. Oh, so it's basically a motor that you just buy, comes with everything, you just slap it on and you're good to go. That's really cool. It should run really well. ATK engines. It should run really well. I had the 6014 for probably a little over a year until it finally died. And then I had the second one, and then that one died after, I want to say, 3 months or so. And now I've ordered Daytona sensors, and so far it's been running pretty good. Haven't had any issues yet, but as soon as I do, you guys know I'm gonna go ahead and post that up. But I haven't had any issues yet. I've only driven a couple hundred miles, maybe 1,000 miles at most. But I'm planning to do some off-roading where I can actually put the thing to the test. Yeah, I don't trust myself to go get a Junkyard 5.3. I'm just getting into this, so a Junkyard 5.3 is probably the best investment in terms of engine knowledge that you can get for yourself. And I always try to tell people to just get engines from the junkyard because one, it'll allow you to be intimate with what you're working on. So when you're putting it together and taking it apart yourself, you know where it's supposed to go. The biggest draw from a crate engine is that all the seals are already good to go. It should be running, it should be broken in. Your cam should be good to go. Everything should just bolt up and light up. The beauty of a junkyard engine is that although it does take a little bit more time, you usually end up saving a ton of money. So, for example, my engine cost me about $300, and then because I bought it from the junkyard, because if I was to buy it from a dismantler, they wanted, I think, $900. So I saved myself $600 there that I then put toward my ignition system or my intake manifold. If I wanted to go with a 6.0, they were anywhere from $1,200 to $1,800. So you can imagine if I was able to find a 6.0 at the junkyard, I would have got that. But in California, there are no 6.0s at the junkyard. So when you're putting it all together and it's a crate motor, you end up, it kind of sounds bad, but you end up a little bit ignorant of how it comes together. So I notice that people who deal with only crate engines or start off with the crate engine end up having more problems because they don't understand how things are supposed to go. And so if you mess up somewhere in the process, you're on tech line a lot. I had this very problem with my friend when he ordered a 4.8 and it was all good to go and installed, ready to go, and he couldn't get it to run and he didn't understand why. And when something goes wrong, you better understand what. Yeah, exactly. James is right. When something's wrong and you know that the intake manifold is supposed to be like this, and you know the headers are supposed to be like this, and you know the front cover is supposed to be like this, later on down the line when something happens, you'll be able to actually take care of it because you've already done it at least once before, or you've actually taken a look at it and said, yeah, this was bad, I should have replaced it, or yeah, it's still pretty good, I'm just going to leave it alone. So you have those options as well for when you decide to do it. I've already got 3 junkyard 5.3s, no, 2 junkyard 5.3s and a 4.8. If you guys look on my Instagram at the Night Wrencher, you guys will be able to see whenever I start up those engines on my personal Instagram. You guys can see that I just put them on the engine stand, put the carb intake on it, let it go, and it starts up. Make sure it doesn't knock, and then I'm good to go. Usually, where I buy my engines at the junkyard, they come with a 60-day warranty, and since I can run them immediately on an engine stand, I can find out if there's an issue or not. But I'm pretty good at deciding what engine's good and what engine's bad at the junkyard. I just take a breaker bar, socket, and a couple extensions, and you stick it on the crank, and I try to move it as fast as I can left and right, see if I hear any kind of clunking, and then I'll spin it a couple times to make sure everything is free, and then I'll do it again left and right just to make sure, because you can hear when an engine when a bad block gets to the junkyard, you can hear it. Like, you can really hear it. So it's really easy to find a good core at the junkyard. Well, if I say I get one from a place here, they just sell pulled motors, what would be a decent price? Say 100K to 150K miles. It's kind of hard to say because dismantlers have a really high price for the things. What'll cost you $400 or $500 at the junkyard will cost you $1,000, maybe even depending on your location. I've seen 5.3s go for $1,500 pre-pulled, and that's because there's not a lot of them in that general area, especially like unpopulated areas. Engines tend to go for a little bit more than, like, let's say like a big city. So I wouldn't pay more than $800 or $900 for a pre-pulled engine with warranty. But you got to make sure that it does run. I mean, you can. I should have probably made how to make your carbureted engine run on an engine stand, but it's actually super easy. If you guys look at the video that I put when I ran the Daytona Sensors ignition box, it's super easy. You just make sure your flywheel's on and all the bolts holding your engine are in place, and you really just let it go. Make sure there's oil in it, and you'll be able to start it up. 4.3 Chevy served me real good as well from late 80s Blazer S10. Those 4.3s last pretty much forever. They're really good motors. I think they're running motors and offer replacements. Yeah, Tyler, I'm not much the ATK packages, but if you decide to go through the junkyard, it's a hassle. I'm not gonna lie. All the people selling them did the same thing and they just sell it for more. Yeah, Infamous Nova's right, but it's true. Like, I hate pulling engines from the junkyard, but I love saving money, so it kind of evens out. So when you go to the junkyard and you go to pull your engine, you're gonna spend the price of the engine. Plus, if you pull it, you can creates intimacy. Exactly. So you know getting. So when you go to the junkyard, you're paying for the engine, the harness, Well, actually, no. You're not getting the harness or the intake or the yeah. You're not getting the harness, the intake, or injectors or computer. So it actually really really cheap. I think you can get it for like $200 or less at the junkyard. You can probably take like a sawzall, like a cordless sawzall, or even like some big pliers or some bolt cutters, cut everything off, pull the intake off and throw it away, and then just buy the heads, the exhaust if you need them, and the block. And I think the blocks go for like 100 or 150, and the heads will go for like $100. So for like 200, 250, yeah, you'll have an engine ready to go, and you don't have to really worry about anything else. Um, if you buy it with the EFI and stuff, they'll probably charge you like $50 for the harness and like another $30 for the PCM and $70 for the intake. So all in all, you'll probably pay like $350, $450 for a complete engine. Some people say they can sell the intakes and the harness, but I haven't been able to sell any of them. So next time I go to the junkyard, I'm just gonna get heads and block. I'm not gonna get the whole thing because the headers are really cheap. I got mine as a long block. Um, so yeah, I'm not trying to deter you from buying any kind of pre-pulled engine, and I'm not trying to deter you from it from a rebuilder. But I mean, if you do the math and you're saving, if you end up saving like over $1,000, then I would definitely go pulling it yourself or getting it from a dismantler. But if you don't save that, if you run all the numbers, you can actually call, right? So if you call like a dismantler, or if you call, ended up getting up a new intake and MSD for $500. Yeah, so you can get secondhand parts too, especially on the. Oh, if you guys aren't there and you guys are doing carbureted LS stuff, jump over to LSX carb swaps, and a lot of times people are selling like their old intakes, like they're upgrading, so they'll go from like a dual plane to a single plane, or they go from a single plane to a dual plane, or they go from a dual plane to a Holley split intake, and you can get really cheap. Or people will give up on their carbureted swaps and go EFI, and then they'll sell their swaps for cheap. So jump over to I think it's on Facebook, the Facebook group LSX Carb Swaps. I think is the name of the page. So jump on there. You guys will be able to buy some used stuff. But anyway, yeah, if do run the math, you can call either the dismantlers and you can say, hey, I need a 5.3 from a 2001 Silverado. How much? And then they'll say $600, $800, $900, and then go online. You can go on Summit. I think the part number for the Holley intake is HL. I think it's HLY 3-00. No, 3-300. I think what the dual plane is. You just got to make sure that it's for. I'm assuming you're going to get a cathedral port heads, so you're going to want to get a cathedral intake, and I think it's 30-300. I don't know. I have the part number in one of my LS swap videos, but the part number is there for the dual plane. I think it's like 270. Yeah, yeah, 510, 300, 130. That's what it is. You're right, Tyler. So then there's that one. So then you add up that cost. I think it's my LS swap was practically free. It's the other parts I added that cost me. Yeah, I do remember that you sold the small block Chevy for the LS, and then I think afterward you wanted to go back to small block Chevy because you got tired of trying to figure out the LS, but it's really not that difficult. Um, so then after that, you're gonna need an ignition box. If you go MSD 6014, I think they're going for like 415 right now. And if you go to Daytona Sensors, it's about 550 more or less. So whichever one of those you decide to go with, I personally like the Daytona box more, but to go MSD, it's not a bad box either. So you add that cost as well. Let's see, 750 street HP, good for a mild LS3. Yeah, I think a 750 will be right up its alley. Let's see, did he say? Let's see, is it a street HP? Yeah, yeah, that's a really good carburetor. For a mild LS3, that's what 500 horsepower. So yeah, it'll be like perfect for that engine. You have to source all new bolts, etc. All my SPCs didn't work. Only the ARP motor mount bolt. Yeah, because all the LSs are metric, but I think the Vortec blocks are metric too. So it's not just small block Chevys. So they had that crossover point when they switched over in the 90s when they switched over to the Vortec blocks. All of that became metric, or at least most of it became metric. And then the LS. So if you're going from a Vortec block to an LS, it's not that hard because all the bolts are pretty much the same. So anyway, Tyler, yeah. So you add up the cost of the ignition box, the intake, a set of headers if you want. Uh, you can go online probably and look up prices, junkyard prices for basically heads and a block. And those I want to say it'll probably run less than $200 if you buy just the heads and the block. Um, maybe 250. So you add all that together, and then you figure out that cost. So if you figure the engine's going to cost 300 from the junkyard, let's say 800 from the dismantler, the MS 400, so that's 1200. The intake, I think they're like 300. I want to say they're $300. So that's 12. Oh, that's 1500. Let's see what else. What else we got? Fuel pump. I mean, you got to source your own fuel pump anyway. Headers are, well, I mean, headers you're going to source them out anyway yourself. So you're looking at about $1,500 on a medium range, maybe 2,000. Yeah, sounds like investment to just go junkyard. At least I wouldn't feel as bad grenading it. You know what? That is a very good point, Tyler. That is an excellent point because when we're new to this stuff, especially with carburetors are very. If you know what you're doing, then it's fine. But if you don't know what you're doing and you're not careful, you will. You know what'll happen? You see this guy that keeps commenting under you, Nova. That guy, I think it was this guy. Correct me if I'm wrong. I think this guy flooded his engine to the point where it wouldn't spin anymore, and then he had to pull the heads off to pull all the fuel out and then relubricate the cylinders. I grenade mine. I'll still have all the good stuff. Yeah. So I think infamous Nova. Correct me if I'm wrong, Nova. Was it you that overfilled your engine and then dried up your cylinders and you had to take it apart? I think it was him. So anyway, if imagine doing that to a brand new $3,000 motor. Wasn't you? Liquid lock. It wasn't you, Nova? Okay, my bad. It wasn't Nova. It was somebody else. I talked to a lot of you guys on Instagram, so I forgot who it was. Oh, I have the full intention of hitting it with 100 or 150 shot. Yeah, well, yeah, see? You're not going to feel, if you do it yourself, it takes a little bit more time. Let's be honest. It's going to take you a little bit more time, but the barrier to entry is a lot lower and you can do a lot more dumb stuff because you'll have a lot of extra money. If you let's see, you can run at least, let's see, from the blow through guys, from the carbureted turbo guys that I talked to, they say they can run up to on stock ring gap. You can run anywhere from 10 to 12 10 to 12 psi on stock ring gap. So I'm pretty sure you can run at least an 100 shot on a 5.3. I don't know if you were going to be able to run a 150 shot, but I'm pretty sure you're safe on a 100 shot, and you don't even have to open it up. I would just replace the seals. Let's see. I'm going to push those limits and let you know. Maybe in 2022, Nova, when you get your engine running, you will let me know. I think Tyler will probably finish before you do, but we will find out because I'm losing faith in you, buddy. It's been like a year. I have a 20-pound spring. Oh, you're going turbo, right? I think that's what it is. 20-pound rent. 20 pounds. 2021. We'll see. We will see. Oh man, you guys are wild. If you don't mind me asking, Tyler, how much is that ATK kit? I'm trying to think, like, how much would they charge you for basically a rebuilt motor with all the goodies? I'm gonna assume somewhere in the 4,000 range. Somebody answer me because the silence is killing me. You guys got quiet all of a sudden. Yeah, 4,100. Okay, look at my video. It's almost there. Okay. Okay, Nova. I'll check it out as soon as I finish up with the live stream. 4100. So even after you take your junkyard engine and you put brand new seals on it, you seal it all up 100%. And you throw new head gaskets on it, and you put a new oil pan gasket on it, and you buy a new oil pan, you're probably gonna save anywhere from 1500 to $2,000, which actually you don't even save the oil pan from the 4100 because you just said that it won't fit in a G body. So add the oil pan, which is what, another $300. So 40 at 41 plus $300, that's $4,400. So you add that price to what you're going to be spending to build it anyway, and you're probably going to save close to $2,000. And I don't know about you, but $2,000 saved means you can buy, let's see, you can buy 3 engines at a dismantler, or you can buy 6 engines at the junkyard. So I think I'd rather buy 2 engines and keep one as a backup. And what you can do, and this is a really good idea, is you can buy two blocks and maybe 2 sets of heads if you want to. Or maybe, well, I don't know, you're spraying it, so you might want to switch over to the 241, 243 heads or the 799 heads. Yeah, I'm not even taking into account getting the 200R4 working and the rear end. 200R4 or 700R4? What's a 200R4? And the rear end. 200. What? Oh, wait. I'm reading it wrong. 2004R. What is a 2004R? Yeah. So yeah, you can get 2 engines. It came in the Buick Grand National. Oh, really? Huh. How does that compare to a 4L60? I'm curious. 2004R, really? Huh. How does it compare to a 4, like strength-wise? How does that compare to a 4L60? Because I think a 5.3, even just a 5.3 within 100 shot of NOS will liquefy a 4L60. A turbo 350 with overdrive. Okay, so it's a pretty beefy trans. 4-speed automatic. Oh, it's weak. Yeah, you might. I think you're gonna want to switch over to a 4L80 anyway. But to just get it running, since you're not gonna need it anyway, and it'll bolt right up. You just need the right flywheel. Before you switch over to a 4L, keep your old flywheel when you buy the engine, but you're gonna need a new flywheel to mate it to this Buick trans. 204R. I hear they're weak. Yeah. Yeah. Well, I mean, it was the Grand National. I think it was a turbo V6, right? I have a turbo 400. Yeah, the turbo 350s, turbo 400s. Those are pretty beefy trans. I've seen them hold up pretty well. I mean, they hold up in the small block Chevy world really, really well. The 700R4s is the ones that I've seen them blow up, but a 700R4 is a 4L60, and I've seen the 383 that I spoke about earlier, earlier in the stream, that blew up 2 700R4s, and it was under warranty, and supposedly for the horsepower it dynoed at, the trans guy said, yeah, it should be able to hold up, and it kept stripping some of the gears. They are weak if you hit it with a bunch of power off the line, but they hold power, turbo power. Yeah, see, that's what I'm thinking too. A lot of maybe like the initial shock from the launch will probably blow it up, but everything else will probably hold it. They are weak, so is a rear end. 7.5 10 bolt with a posi. Without a posi. Yeah, so you're probably gonna either swap that out to a 12 bolt or a 14 bolt, or my favorite is the 8.8, but I don't know if the 8.8s will hold up. I mean, they should. They're really good differentials, but an 8.8 super cheap from the junkyard too. So if you do end up going to the junkyard, there are plenty of videos out there that show you how to go about taking it out of the junkyard. It's going to take you a couple hours unless you find one that is like half taken apart. But you have to make sure that I got to make a video on this on how to find a good junkyard engine. But it shouldn't be too difficult. Run it, break it, replace, and repeat. If you do it budget, you have that luxury. Let's see. Yeah, I was trying to run the numbers in my head, but I lost track. We started chatting, but yeah, it's up to you, Tyler. However you decide to go about it. I think everybody else here says just go to the junkyard. It's easy to say that, just go to the junkyard, but I don't know what your schedule is like. I don't know if you're super busy. I don't know if you have kids that you got to take care of. Everybody's situation is different, but at least give a dismantler a chance, because you are paying a little bit of a premium, probably twice as much as you would from the junkyard, if not a little bit more. But it's still cheaper than buying it like a rebuilt engine off the from a rebuilder. If you were a seasoned racer that has plenty of engine experience, you know exactly what this specific engine wants and how it wants it. I would say, yeah, go get a crate engine, because they've already done all the work for you. Engine's good to go, clean, ready to fire up, and done. But you're a beginner like most of us here, so buying a $4,000 motor, or I guess if you take off all the accessories, a $3,000 motor, it's kind of counterintuitive, because it's not, you don't really learn anything from a built engine. If it survives, then blow it up, then you are in deep trouble, because I don't think the warranty covers nitrous, and I don't think it'll cover hydrolock or poor ignition timing. If you get your MSD 6014 and you run 36 degrees all the way through and it ends up being too much, then you're probably gonna start melting pistons. Kuda 64, good to see you, Kuda. How much should I charge for help tuning a carburetor? It's hard to say, because every situation is different. Usually I don't charge like my friends and stuff charge it. When I was tuning the small block Chevy, it probably took me like 3 hours. If I was to charge somebody, I always it's really difficult to gauge prices, and a lot of it has to do with 5,000. They will keep coming back. If it really depends on like the air, and it also depends on what it is. If it's just like a general tune, like what I did, like basically take the carburetor apart, get yourself a plan of what all the orifices are, where's your starting point, start running it, drive it, figuring out where all the hesitation is, where the bogs is, stuff like that. You're gonna start putting in hours, and let's say you run it on the cheap end, $60 an hour. 3 hours, that's $180. So that's usually my going rate is $60. That's like whenever I gauge a job like that, I always kind of just go, okay, $60 an hour, and just figure out the hours. So if you're gonna go through the whole thing, because I mean they're paying for your expertise, and it's something that they can't figure out themselves anyway, and you don't want to be the cheapest guy, because then you're gonna get all the bunch of all the crackheads out there that want it done for free. But you don't also want it too expensive to the point where if you mess up somewhere, it's not like, wow, I'm paying you $1,000 to tune it and it's not perfect. You got to leave yourself a little bit of a wiggle room. Tyler, yeah, I think that's a better bet to go with the junkyard. All the money I'd save can go to that trans and rear end. But yeah, being a beginner, I guess I just need to jump in feet first. Go to the junkyard, take a random LS apart. Plus, if I get multiple engines, I can buy another car for it. No more cars. More engines, not more cars. More cars is bad. Learn from that, then go Go and get a different LS. Oh my god, you guys are bad. Yeah. So, I tuning a carburetor. Kuda. I don't know how good you are with tuning a carburetor. If you're like really good, um, then I would have no problem saying, yeah, charge what you think is best. I start off at like a $60 baseline just to make sure that usually it's like on a Sunday, maybe a Saturday. So it's like your day off anyway, so you're just making a couple extra $100. But sometimes, man, if something goes wrong and it has nothing to do with what you do, like let's say the let's say it's on an HEI and the HEI module goes out, or a spark plug wire breaks, or whatever, then they're gonna go after you, and that's always a hassle. And that's why whenever I do carburetors for friends, I don't charge them or anything, because I'm aware that things can go haywire. If I had to do it for a client, for a customer, I would like be very careful with how everything gets done, make sure everything is good to go. But don't ever cheap yourself when you're doing jobs like that, because carburetor knowledge, as you guys know and I know, is very hard to come by. And even if you've watched my videos and everything, actually going into the carburetor, um, deciding what circuits do what, especially if the car you're working on doesn't have a wideband, it's all by ear, and it's all by basically taste and touch and sound, that you've got to decide where the timing's got to be, where the jetting's got to be, where the transition's got to be. Uh, so you just have to be, you just got to be careful. And you got to know. So if you do go ahead and do the job, I wish you the best of luck on that one. If you do end up charging something, let me know how much you end up charging, so I have a general idea. People are charging out there. Like I said, I don't know what there's no carburetor tuning shops anywhere around here. So it's not like I can just go somewhere and be like, hey, how much do you guys charge? There's like a dyno shop, like a tune, like somewhere to get your car dynoed, and they do a little bit of tuning, but it's a big shop, and I think they charge $100 an hour. But that's a big shop. And it's like $100 an hour on the dyno. So I don't know. It's kind of weird. Yeah, it takes a lot of time. You can invest several hours into a carburetor easy. I always start off with the timing map first, or the timing first, before I ever touch the carburetor. So on a standard carburetor or a carbureted engine, before I even, like, if it's a performance engine or something that's like hot roddy, I've been struggling getting my carb tuned. Yeah, Kevin, do you have a wideband on your engine, Kevin? I find an empty road. Find an empty road and you can tune there. Start off with timing, then acceleration. Yeah, you basically take it, you break it up into sections. Timing is always first, though. Yeah, AEM wideband. Well, I mean, I think you've written some comments, asking some questions. I'm pretty sure you've asked me some questions on some of my videos, and I've had a chance to answer some of them. Would you say keep the stock coil packs or get something from the junkyard? Well, I mean, the stock coil packs are gonna do you really well. I would not buy any MSD coil packs 100%. If you get a chance to join that carburetor group on Facebook, they're all gonna tell you that they end up buying the set of coil packs, and then within a couple months they end up selling them because they have issues with them. They're not very reliable. I end up just, whenever I go to the junkyard, I'll pocket like 2 or 3 of them, and then so now I have an assortment of LS coil packs in case one ever goes out. I've only ever had one go out. I think maybe 2. You can tell because at low RPMs it'll start stuttering, hesitation, but then at highways and everything it'll run fine. Usually under higher load, low vacuum situations, you're gonna start noticing the coil packs go out. But yeah, as for the carburetor stuff, it is even for someone like me that messes with it every day, it still will take me a couple hours to go through, even though I have the wideband. Uh, Going through and making the changes. Every time you make a change, you have to take the whole thing apart again. So I go through the ignition timing first, and I'll try to recurve if it has an aftermarket distributor. I'll try to recurve the distributor first, make sure we're at the timing that we need to, and then we'll set a baseline idle to make sure it can go into gear if it's automatic or it won't stall. And then the next thing is just getting the transition in, and then after the transition, reset idle, and then go into the main jets. When it's running good, it has a good running carbureted vehicle has such a distinct sound. Some of you guys might be able to corroborate that, but a good running, clean carbureted vehicle, it doesn't matter if it has the same headers as an EFI application, same exhaust as an EFI application, same cam, same timing map. A carbureted engine sounds throatier and deeper than an EFI application. And there's something mesmerizing about the asymmetrical idling that a carburetor does, because an EFI application with the cam kind of does like, you know, it'll always have like the same amount of highs and lows when it has a cam. It'll be very symmetrical in its RPM because of the idle air control valve, whereas a carburetor will kind of just go like, you know, and it's a very distinct sound. It's very different, and wide open throttle is different. So like, because of the way set up, you have two small bores up in the front, and then at wide open throttle, the secondaries open up. So you'll get, oh man, I just got a cramp on my hand. Oh, that hurts. Oh man, I just got a cramp. Oh, that hurt. Oh man. Oh, that hurt. Oh, Jesus. Okay. Yeah. So anyway, when you're driving around normally, you're on the primaries, and then once you go into the secondaries, those things will just the engine will just scream. It'll just scream like crazy. So it's a really nice sound. I just put a 4150 on my 66 GT in the barn, idling next to my 360 W35 with ProFlow 4 Edelbrock EFI. The carb sounds throatier. Yeah, see, Francis knows what I'm talking about. It's just, it's different. 350. Oh, so it's a Dodge. Yeah, it's a Dodge. Dodge 5.9. Oh no, I think I accidentally deleted your message. What did I do? Uh-oh. I gotta be more careful when I touch the screen. Yeah. Oh yeah, I remember, Francis. Yeah, I've had a chat with you before on the messages. I do remember that you were telling me about it. Yeah, the carburetors, they have a very beautiful sound. Actually, Francis, are you the one that was looking for parts for a full-time Dana 44? I think you sent me an email one time. I might be wrong though. Maybe. I might be wrong. Yeah, carburetors have a beautiful sound. That's one of the main reasons why I decided to switch over to ditch the EFI and go carbureted on the LS, because a truck is supposed to sound like a truck. I have a Dana 60, others not full-time. Oh, okay. So no, it was a different gentleman that I was talking to. But yeah, I do remember your name. Actually, I think it was like 2 weeks ago, 3 weeks ago, that we had a conversation on the messages. But yeah, one of the big draws going into the carburetor game was the sound. It has aside. It's super fun when I tune carburetors, whether it's for me or for my friends or whatever. I always have a really fun time. It's always like going through, figuring out all the problems, figuring out where all the orifices are, getting the baseline, and then going forward and doing the tune. That I always have a really fun time doing it, and time just kind of like flies by, you know. Um, versus like getting a laptop and doing the tune, and or maybe getting it on the dyno and getting a tune on it. It's just very impersonal, you know. It's I don't know if I don't know how many people in the chat right now have ever done EFI tunes, but they are a hassle. They are a hassle, and you really can't. You can do it with the wideband, but it is difficult, you know, because everything you can increase everything and decrease everything by percentage, depending on what you're seeing on your wideband, but it is a little complicated. Eat bananas to help with cramps. You know, I've heard that, and I haven't had bananas in a long time, and I've actually been getting a lot of cramps. So I might have to start buying some bananas, because that thing was bad. When I close my hand right now, oof, that thing was oof, it was bad. I haven't had a cramp like that in a while. That hurt. Android EFI, the Edelbrock EFI, that has a self-learning function though, doesn't it? Can you explain the wideband? Yeah, of course. How you like that, Francis? Yeah, so a wideband is the wideband O2 sensor gauge is basically a gauge that will take your reading out of your exhaust, and what it'll do is it'll measure the lack of air per square inch of exhaust flow. So basically, when when you're running lean, your AFR gauge will read lean. When you're misfiring, your AFR gauge will read lean. When you're running rich, it'll read rich. When you're misfiring while you're running rich, it'll read lean, because unburned fuel or misfires will produce excessive amounts of air that goes into the exhaust, and it'll trick the wideband. But that's only when you have a problem. If it's running the way it's supposed to, then it should read rich and it should read lean. Usually, the go-to number is 13 to 1. 13 and a half to 1 is the sweet spot for power and performance and drivability. So with the wideband, what it'll do is when you have it on and you hook it up to your dash, and it's a little round gauge, kind of like a vacuum gauge, only for exhaust flow. No computer on the yeah. So it's a standalone system. So when you buy one, it'll come with a sensor, it'll come with the harness, it'll come with the gauge itself, and then you really just have to wire it up to power and ground, and that's it. The rest is done by the little gauge pod. You don't need a computer or anything, but you do have to add that O2 sensor. It won't have. It's just a tool. It's a gauge and a tool. I like to call it a tool. So it'll help you tune your carburetor. It'll save you probably 75% of the time. So what it'll do is when you know your carburetor, or as good as you know that it works, right? So what happens is, let's say you start it up, you let your engine fully warm up because you don't want to do any kind of tuning when it's cold. So you let it fully warm up, you take it out for a drive, and then you'll notice that you're going to start getting these numbers come up that'll tell you whether you're running lean, anything above 14 to 1, or if you're running rich, anything below 12 and a half to run. And so you're going to start adjusting these settings. The beauty of a carburetor is that when you adjust a setting, it affects the entire curve. So when you tune a carburetor from scratch, you want to do it in a specific order, because everything that you do on the bottom will affect the top, which is why I always tune the secondaries last. Because if your primaries are running rich, your secondaries will look like they're running rich. Or if your transition's running rich, it'll make your main jets look like it's running rich, which is why I do idle, transition, idle, main jets, secondaries, or you can do your power valve anywhere in between. But I always do transition before main jets. because that's a big thing. And then your accelerator pump can be done anywhere as well, because each individual circuit belongs to a different part of your throttle position. So closed is idle, slightly open transition, slightly more open is main jets, and then secondary jets. And then if you floor it, that's power valve. Or if you have if you happen to have a vacuum gauge, you can purposely activate the power valve by going into the low vacuum situations on purpose to see where your AFR goes, and then you can decide, yeah, it's dumping too much fuel too early, I got to move it back. Or it's not dumping enough fuel early enough, I got to move it up. Or it's just dumping too much fuel, I've got to change the orifice of the PVCR. And you can't really do that by ear because a lot of times you don't know because it's really hard to tell unless you're consistently on the power valve and then checking your spark plugs. But that's what the wideband is for. You can go into different situations, and having a wideband and a vacuum gauge right next to each other, like to tune, is the most, like, there's nothing better. There's nothing better than having a wideband and a vacuum gauge next to each other, and you can make your carburetor do whatever you want, and you can get whatever readings that you want as well. How much does it cost? It costs. The one that I got, I really like the one that I have. It's been running great for almost 2 years. It's an AEM. I think I have a part number for it in one of my recent videos. I'll have to look for it, but $180. So it's a lot, but like I said before, it will pay for itself. I'm also tempted to go manual too when I swap, because why not? Well, if you plan on, well, I don't know. I used to promote manual transmissions a lot, especially when I was younger, because they're just so cool. Very few people know how to drive manual, but a built automatic transmission will outshift any manual transmission, like hands down. Yeah, James, it's definitely worth it. It'll make tuning a breeze. And after you got it dialed in, you can just keep it on there and always look for it. It'll always, whenever you have an issue, you'll always be able to glance at your AFR gauge and see, hey, am I having an issue with carburetor, or if it's something else. Diagnosis is a breeze as soon as you have an AFR gauge. It's just such an amazing tool. I always recommend anybody that can get one should get one on their carbureted vehicles. It's excellent. And then you don't have, after you fully tune it up, you don't even have to keep it there. If you have another vehicle you want to try it on, you just pull it off of your vehicle and then install it on another vehicle and then do it again if you really want to. Or if you always want to have it there so you always know what's going on, then you could always have it there. That's how I have it on mine. Whenever I do because I swap a lot of carburetors on my engine to just do a lot of testing, and having that AFR gauge there lets me dial everything in, boom, 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 and within a couple hours it's 100% tuned, which is really, really nice. Let's see. The mount location is important, even the angle. My Pro Floor 4 has problems intake related with install on 3 and 5. Bolts wouldn't fit, had to use studs. That's weird. And you're right, a solid automatic can outperform a manual 98% of the time. Yeah, you've got to, I mean, you can kind of cheat. I drove a stick now, the fun outweighs the speed of an automatic to me. Yeah, see, you can, a lot of like popular transmissions, like a lot of Ford transmissions, the NV series of transmissions, the R150 that's really or the R154 that's really popular. A lot of these transmissions, the T5, T56s, they have short shifter and short throw shifter add-ons that you can throw on there that really help with shifting. But if you plan to race, especially if you plan to race for money, I would definitely stick to an automatic. If it's more of a cruiser, daily driver with some racing sometimes, then a manual transmission is great. You can't beat the fun of a manual transmission, but you probably can't beat an automatic in a race with a regular manual transmission. But here's another thing too: a manual transmission, I definitely plan on racing. Here's another thing too: is that a manual transmission, even a weaker manual transmission, like a smaller one, can hold up to a lot of power. A T5 that came out of a Mustang that only made 150 horsepower survives 300 plus horsepower. The only advantage of a manual is that you can force a lower gear when an auto can lock you out. That's true unless you run like a manual valve body, which is a little bit different. I built Turbo 400 with manual forward valve body. Yeah, I was thinking like a F-body T56. An F-body T56 is a really good trans. 600 horsepower, I think, is what they can do. 500 at least. Quarter mile. All my competitors when I raced my Chevy 2 were automatics. Me too. Yeah, it's just a well-built automatic. It's just really. But if it's a cruiser with mild racing, and it's not a dedicated race car, then a manual is no problem. Plus, you should be able to run a pretty good amount of boost through. T56 is an excellent transmission, really stout. The T5s are really good transmissions up until about 400 horsepower, I think. Even my R150 Toyota transmission, which is, to put this in perspective, the transmission that's in my truck on 35-inch tires, pushing at least 250 to the wheels, that transmission came out of an engine, or came out of a truck with an engine that was pushing 110 horsepower to the rear wheels on 31 tires. Actually, 31s were an option. Probably 225 tires, which are like 28s. So I'm putting over twice the amount of horsepower, twice the amount of torque. The torque on those engines was like 125 to the wheels. I'm close to 300, like 295 torque. So twice the amount of torque, twice the amount of horsepower, way bigger tires, at least from stock 5 or 6 inches bigger than OEM. And the engine or the transmission has been holding up flawlessly. I haven't been able to break anything, thank goodness. And I'm pretty done with that stuff. I do donuts with it, I launch it, I pull trailers with it, and it's holding up, which well, it's an Aisin trans, so you know Aisin's a really good brand. But aside from that, manual transmissions in general just hold up really well to abuse, because you can, if you damage it a little bit, it'll hold. Automatic transmissions, if you damage it a little bit, it goes downhill from there, you know. My diesels around 600 torque are all automatics. 5 R100s, Allison, etc. The 5 R100s are 300,000 miles transmission. Yeah, that's true. The especially on the Fords, the 4 R100s out of the older Fords, the 5 R110s out of the newer Fords, those were all really good transmissions. The issues with those is that you had to make sure that your oil cooler was in excellent condition, that the radiator was in good condition, and if you needed to, add another oil cooler so that we can keep the temps down, because they work really hard. Another transmission that we've had really good luck with are the I think it's what, the 47 REs out of the Cummins, the Dodge transmissions. A lot of people say that that they suck because they blow up a lot, but they only blow up after you modify them. We've had, and we have, several 5.9s, the original transmissions, the 47 REs, I believe, and we still have the original transmissions. Excellent trans, the 47 RE. Yeah. So we've had those go for 300,000+ miles, and we've sold the truck after that. We've had at least 3 that we've made it to over 250,000, and with the original transmission, and we've sold the truck, and they're still in service. There's only been, because we go through a lot of these trucks, we've probably had over 15 of these trucks with the 5.9s, different years, 12 valves and 24 valves. There's only been one that we had to have the transmission rebuilt, but that was because we had a tuner on it, or we bought it and it came with a tuner, and it It pulled way more boost, and we were doing stuff that we didn't have to do to it. So that was the only one we've ever blown up a transmission. But we have two, one that has an MV 4500 and an MV 3500, and both of those have been holding up just fine, over 300,000 miles on both of them. How is a 750 Speed Demon with mechanical secondaries for a 6.0 with 862 heads? Well, the heads are good, although the ports are smaller and the valve, but the compression ratio is significantly higher, so it'll probably get you to the 10 and a half to 1 range. But it doesn't. The stock 5.3 heads, Richard Holdner has done tests on them. They're good for 550 horsepower, no problem, unported. So a 750, let's see, a 6.0 will get you right around 400 horsepower. If you put a cam in it, it's probably 450 horsepower. So a 750 with mechanical secondaries, I think you're a little bit on the big side. You're a little bit on the big side, but it's not unbearable. You're gonna probably want to do a little bit of jet tuning, but for the most part, it should run really well. You are a little bit on the bigger side. It's like marginal. You're at the point where you can either run like a 680 or 670, 680, or a 750. It's kind of like a toss up right now because you're like in that in between. You can run it if you're gonna be using it more for like recreational purposes, then the 750 is gonna be great. If it's more for like cruising and like around town kind of stuff, I would look into like a 680 or 670, or a 650 Speed Demon would actually run really well. That would be the 650 with mechanical secondaries. Actually, that's this one. That's what this one is. This is the 650 Speed Demon. So it doesn't have the choke horn, and then it has the 650 Venturis with the 750 base plate. And the 650s actually flow more than 650 CFMs. They actually flow closer to 700 because of the radius entries. So really, they're labeled like that for marketing purposes and to easily tell which is for what. So if we're talking Speed Demon specifically, I think a 650 would probably be a 650 Speed Demon would probably be a little bit of a better choice. But if you plan to grow from there, then a 750 will work just as well. You're not going to be losing any kind of low with 450 horsepower. You're not going to be losing, and the 862 heads, you're not going to be losing any kind of low end performance by switching over to a 750. If anything, you're going to lose maybe 5 pounds of torque, maybe 5 horsepower, but it's nothing that you'll be able to feel because of the number one, displacement, number two, the small chamber heads, which produce a really good amount of torque and high velocity. So you're going to be able to pull through that 750 no problem, without a doubt. I think you should have no issues. Let's see. I have a 750 double pumper on a 5.3 with 706 heads. The difference between Unova and Daniel is that your 5.3 is going to be running boost, and I don't think his is going to be running boost. So that's why you want to switch over to a 750. So I have a 750 currently on mine as well, but it's only because I haven't finished building the 575. But if you're, and also you're racing, different carburetors for, like, carburetor selection is different whether you're using it for daily driving or you're using it for racing. So with racing, you want to go big enough so that you have no restriction on the top end. For drivability, you want to get it small enough so it doesn't give you any kind of restriction on the low end, basically. Does the 6014 come with presets for timing and stuff? Just base stuff to get you up and running. Obviously, I'm going to have to put some time in with the carb being new. It'll still be an ABS2. An ABS2 will run it okay as long as it's tuned up properly. I try to run an ABS2. I tried to run an ABS2 on my 5.3 and I didn't like it. But other people have run an ABS2 on theirs. It could just be my specific carburetor. Actually, I'm pretty sure it was a carburetor because we tried to run it on a different engine and we had issues there as well. So the 6014 comes with the harness and it comes with the standard truck map, the truck HO, an LS1 map, LS6 map, and like something else. It comes with like 6 presets, so you should be able to running the preset that it comes with from the factory is the standard truck setting. Either way, all of those settings are pretty garbage. You're gonna want to put in a custom map yourself anyway. None of those give you the correct timing curve for what you want to do anyway. On every LS that we've tuned on a 6014, we've never used the presets because a lot of them either have too much timing on the top or not enough timing on the bottom. So you're going to be messing with it anyway. But to get it running, the stock truck timing map is perfect, just to get it going and get you introduced into what everything does. So you should be okay. That 4150 I just put on the 6.4, the 390 is 670 vacuum secondaries. Yeah, I didn't used to like the vacuum secondary carburetors until I started daily driving them, and now I really like the way vacuum secondaries drive. But Daniel, 4150 with a mild vacuum secondaries is a numbers matching original type car. Mild. I've seen that, and a lot of the OEMs really preferred, even the performance ones really preferred vacuum secondaries because it's really easy to bog on the street. It's really easy to bog into the secondaries with the mechanical secondaries, whereas the vacuum secondaries, although you get that little bit of a delay, but you also feel that hit when the secondaries finally catch up, which is really nice. Daniel, if you're running a 6.0 with the stock cam, 706 heads or 862, basically the same thing. I think a 750 mechanical secondary are probably going to be a little bit too big. I don't think you're going to have any issues with it. I don't think you're going to have problems with it. But if you're going to be mainly driving it on the street and driving it around town, you're going to get a little bit better drivability, a little bit more performance, a little bit more torque. Switching over to a 670 or 750, or a 670 or 680. But if you already have the 750, then throw it on. You're not really gonna. It's not anything that's detrimental to your performance. Plus, the 750s do make a little bit more power, especially at that cubic inch and that RPM, or at that horsepower, a little bit more than the 650 will. But if you're looking for a carburetor, I'd probably go with like a 670 Street Avenger or a 680 Quick Fuel. I think they have I think the Quick Fuels, or I think it's a Brawler. I'm not sure. But do look into it. If you've already bought one, you already have it, or if there's one for sale for cheap, then grab it. You could always jet it to whatever you need it to, especially if you have a wideband. But if you already have it, then run what you got. It's gonna run for sure. Yeah, the ABS2 is what I had for the original motor when I ripped out the ECM because Quadrajet was part of that system. Yeah, the Q-Jet was they're decent carburetors. A lot of people swear by them, but they're no good in like on good engines, if you know what I mean. Even the carburetor, even the Edelbrocks, they're not that great on like high compression, good flowing heads, good ignition map. Though the weaknesses of the Quadrajet and the Edelbrock really start to show when you put them on like really good engines, really good breathing, really good running engines. When you put them on small block Chevys that don't breathe as well as an LS and stuff like that, a Quadrajet will definitely run better than a Holley will, at least in stock trim. The Street Avengers can be found for 395 new. Quadrajet, even after quality rebuild, they're never quite right. They're never quite right if you've messed with the engine at all. If you put a cam in it, if you change the ignition timing, if you put an intake on it, the Quadrajets are set up for like off the line, brand new from the factory with factory exhaust, factory intake, factory everything, and they're dialed in to run perfectly for those settings. As soon as you deviate from that, the vacuum, you're gonna have to start changing springs, changing diaphragms, changing plungers to get it to where it needs to be. GM spent a lot of money getting each carburetor tuned for their 327s or 350s or 305s, and they all run really well in factory trim. As soon as you start modifying them, you're much better off getting a Holley. It's much easier, much faster to get it tuned the way you want to. Let's see, 86 was the first year they put in the ECM on the El Camino, so it controlled the distributor, spark, and carb and trans lockup. Yeah, those were a pain. Those are a pain for sure. I think you can easily, after you swap over to after you swap over to the LS, you should be able to take care of most of that. The lockup is actually really easy if you keep the automatic overdrive. There's a lot of write-ups on how you can keep the lockup working perfectly. Quadrajet, definitely stock only, no mods as you're pointing out. Yeah, that's a thing. Edelbrocks are a little bit more forgiving, but the Quadrajets, they're excellent for OEM applications. They're no good on LSs. That's why nobody runs one on an LS, because they're no good. Tuning is a nightmare on those things. What's a wideband? So a wideband, I have a video on this if you want to go through the channel. Daniel, right? Yeah, Daniel. Yeah, I have a video that goes through the wideband, and it goes a comparison between a wideband and a like standard spark plug reading. But the gist is basically it's a gauge, and I just explained this to what did I explain? Did I explain it to Francis? I think I explained it to Francis or James. Yeah, I think I explained it to James actually. Yeah. So a wideband, basically, it's an O2 sensor that you put in your exhaust, and a gauge that you hook up to your dash, and it basically has an internal computer. You don't have to plug it into any kind of computer or any external anything. It's power and ground, and basically your gauge will tell you how your exhaust is running. So if you're running rich, if you're running lean, your gauge will tell you immediately. So after you're warmed up and you get it driving, you're going to be able to tell if you're going to be able to see a couple things. The first thing is obviously your idle. So you're going to be able to see if you have a lean idle, rich idle. You're also going to be able to decipher between the different circuits of the carburetor. So when it's time to do actual tuning, you're going to be able to tell if it's if your issues are in the transition, if they're in the accelerator pump, if they're in the main jets, secondary jets, transition to the secondary jets. If you can tell how early your vacuum diaphragm is opening up, and obviously it doesn't say vacuum diaphragm is opening up. You can tell by the way the numbers are moving. So it's a digital gauge. So if you're accelerating and you're accelerating at 13.5 and you floor it, you're going to see it go lean, and then all of a sudden it's going to start going rich because your secondaries will start to open. That's when it starts going lean. And then it's going to start pulling fuel. That's when it starts going rich. So you're going to be able to tell every single part of it, and you're going to be able to diagnose your carburetor and tune it exactly how you need it to. So for example, if you open up your secondaries and your secondaries drop you down to 11.5 to 1, you know you got to go down at least 2 jet sizes in the secondaries. Or if you're driving around and you're cruising around and your cruise is at 12.5 to 1, you know you have to lean out either your jetting or your transition, and that depends on where your foot is on the throttle, because you could be on the transition, which will be right above idle, where it'll probably be main jets, which is like about 25% from the throttle. And so if you'll be able to tell in relation from your foot to your wideband where you are in the tuning area of your carburetor. The next thing you can do is also if you hook up a vacuum gauge to it and you head up and you have your AFR gauge and your vacuum gauge hooked up at the same time, you can also force your carburetor to go into the power valve circuit, and you can tell either your power valve is opening up too early and causing it to run too rich, if it's opening up too late and it's causing it to run too lean, or if the orifice of the power valve is too small, not enough fuel when it opens up, or if it's too big and it's shooting out too much fuel when it opens up. Because you have to remember that after you're at wide open throttle, you are using your primary jets, secondary jets, and your power valve. So when you're doing your tuning, you want to get your main jets and your power valve tuned up before you go into the secondaries, because at wide open throttle or into the power valve, your power valve is going to add fuel to the secondaries. But if you tune the secondaries first and then you tune the power valve, if you take away fuel from the power valve, like let's say you change the orifices, now your secondary tuning is going to have to change to compensate for too much fuel or not enough fuel on that as well. So we just went through this a little bit earlier, but I like to reiterate the fact that a wideband is absolutely essential for carburetor tuning. If you have a carburetor vehicle, get yourself a wideband. It, like I said earlier, it will pay for itself, and it won't even take that long. It can literally save your engine. You can be running rich and not know it. You can be running just rich enough that it starts to wash out some of your cylinders, and you will never even know unless you consistently pull out the spark plugs. But a lot of carburetors run so bad, and people have them so poorly tuned up that they always run bad, so their spark plugs are always black. And if they had a wideband and they took the time to learn how to tune it, their spark plugs would always be a light brown, medium brown, and they would have really not good gas mileage, but they would have decent gas mileage. Narrow pulls from the O2 sensor wideband reads the cylinder internal combustion. Narrow pulls from the O2 sensor wideband reads the cylinder internal combustion. What about fuel pumps? Holley Blue or Carter internal regulated or whatever. On it really depends on what you want to do. You said that you're not gonna about going manual, so you're probably not going to go into too serious of a race, so you probably don't have to worry about a fuel cell. And or actually, don't you had EFI on your El Camino, right? So you should have an electric fuel pump already in there, or no? I think you do. Oh, that's right. Carburetor quadrijet. I remember now. The Holley Blue pump is the most popular pump to use. Yeah, mechanical fuel pump. If it was EFI, I forgot. I'm confused. If it was EFI, then I would say just use this pump that's already inside your tank, but you don't have one, so yeah. So the Holley Blue pump is a really good pump. Everybody seems to like it. EFI using mechanical pump. No. Tyler has the stock quadrijet for the old small block, and I thought he was on EFI, so I thought he had an electric pump, but he had a carburetor with a mechanical pump. EFI, yeah, it won't work. The mechanical pumps can't put out nearly as much pressure for EFI. Yeah, so the Holley Blue pump is pretty much the go-to. You can retrofit your tank to accept an in-tank pump like a Walbro 255. I'm using, I have a video, Tyler, on retrofitting your stock carburetor tank to accept a electronic fuel pump. but that one's going to need a regulator on it. In reality, you should have a regulator, a return style regulator on your system anyway. The deadhead systems work okay for racing, but you're going to be doing, I'm assuming you're going to be doing a lot of street driving. You really want a externally regulated fuel system, Holley blue, Holley red, whatever, card or anything. Number one, if you have it on a return system, your pumps last a lot longer. The pumps work a lot less because they're always at a consistent pressure. They don't have any kind of pressure spikes. So your fuel is always flowing through it. Let's see. So I watched Uncle Tony's video. He said the blue pump can't really pull from the tank. It's more of a pushing pump, and don't want to get into opinions and who's right and who's wrong. But yeah. I mean, it's not, you got, the thing about the blue pump is that you gotta move it as close to the tank as possible. You know, it will do a little bit of sucking, and especially if the pump is below the fuel tank, or at least pretty close, you should be able to siphon it pretty easily. The issue is that a lot of dry starts will probably kill it. I had a Holley blue for years. Yeah, so they're really good pumps. You just have to make sure you place them correctly. There's nothing wrong with them. I personally would probably find a way. They make retrofit kits for the G bodies. I'm pretty sure they do, where you can run one in the tank. I've seen that I just sold mine before the swap. I've seen that the Holley blue pumps make a lot of noise. They're kind of noisy. Yeah, he said priming would be a good idea, if I recall. Yeah, I mean, he also mentioned that you can use two pumps, but that'd be a little bit redundant. But you could use two pumps if you wanted to. The older Ford Broncos used to use two pumps, but then when one died, it would kill the other one because it would block one, and then like you'd have issues. So I probably wouldn't use two pumps. Very few manufacturers have ever used two pumps. Yeah, they do. Yeah, see, so the on my friend's 383, he has a fuel. Let's see, what fuel pressure do I run for? On any Holley, the rule of thumb is run just enough fuel pressure that it doesn't blow through the needle and seat, and usually that's around 6 to 6.5 psi. But it will vary a little bit. In the diesel world, I'm a tech. Very typical to take 3 to 5 psi, raise it to yeah. Oh, I remember now. Yeah, we did have a conversation about this. Yeah, I used to work on the Power Strokes, and they have a lift pump that'll feed the injection pump, and then the injection pump will create the pressure. The difference is that because of the way diesels work in the RPM range, because of the RPM range, the helper pump can feed the flow or it can feed the injection pump more than enough fuel at a low pressure, but the injection pump takes the volume and increases the pressure to whatever it needs it to be. So all low pressure pump, it's a high volume pump, and although the injection pump is a high pressure pump, it's a low volume pump. So they both flow the same amount, but one does it as a higher pressure than the other one because the other one's more worried about keeping the injection pump alive, because the injection pump doesn't do any kind of sucking, it just pushes, which is going back to the whole situation with the Holley blue pump. I don't know how much driving Infamous Nova did on the blue pump, but I've had some pretty personal experience with the Holley blue pump, and I haven't had any of them go out. But I always recommend doing a return style system. It just runs, the fuel runs cooler, maintains pressure spikes to a minimum, and you can typically regulate your fuel almost exactly to what you need it to on a return style system, because the fuel's consistently flowing, so you can adjust your regulator to exactly what you want. And it doesn't matter if the fuel gets hot, it doesn't matter if the fuel gets cold. If it's a cold day or a hot day, the regulator will be able to maintain it because fuel is always running through it, and there was no return. Yeah, that's the beauty of the blue pumps because they're internally regulated. So you should be able to just hook it up and go. The issue is that, like I mentioned earlier, Nova, I was talking to one of my subs on the my subs on Instagram, and he had a Holley blue pump, and he had a brand new carburetor, and he didn't bother to check the pressure, and the Holley blue pump was just high, just a hair high, too high, that he ended up flooding his whole engine because he left the key on and he didn't realize it was dripping into the system. So although most people it'll run perfect, for some people, could be anybody. For some people, you might run into issues, but it's not the norm. Oh, you had a regulator on it as well. See, so that makes a little bit of a difference as well. You should be running a regulator, so that's a really good idea. France's return style system is superior on gas and diesel. Engage right at the carb. Yeah, I have a setup similar to yours. Not right at the carb, but very close. The return system is they tried deadheading system, and they have it now on the what do you call it, on the direct injection vehicles, but Ford tried a deadhead system on the 7.3s. I believe they're all deadhead systems as well. A common modification to the 7.3 is to convert it to a return system, so you always have diesel running, fresh diesel running. It prevents fuel starvation at higher RPMs, higher power levels. Same thing to some of the 4.6, 5.4 systems. When on the stock deadhead systems, when they put the superchargers on them, they have to install a return system on it because it'll start starving out the system. Same exact thing as in the diesels. So what'll happen is when it's a deadhead system, but now I have a return, regular, and no. You should still have a gauge on it, Nova. Put the gauge back on. So what happens is when it's a deadheaded system, you have all the fuel pushing toward it. As fuel runs out, more fuel is coming in. So what'll happen is at low RPM, low load, the amount of fuel coming in can fill up the void fast enough as fast as the fuel is being used up. But as soon as you increase power level, fuel demand, and RPM, you're going to run out of fuel here, and the fuel doesn't have enough time to fill in the gaps. So even if it's a really good pump, you can't beat physics. You have to turn that thing up way high so you can make sure that the fuel coming in will be able to close up those air gaps, those vacuum gaps, essentially. So with the return style system, your fuel system is always at the same pressure. So it doesn't matter how much you're using up, as long as the pump can supply it, you're always going to have fuel in the system regardless. Then you run into issues when your pump is not strong enough to maintain the pressure, and that is a different story altogether. But as long as you have your return system set up appropriately, you should never have a starvation issue, provided that your pump can supply enough food for your engine. So there is that as well. But my throat is starting to get a little raspy, so I think I'm gonna go ahead and call it a night tonight. It's been really fun. I always have fun doing these live streams with you fellas. Infamous Nova, it's always good to find out all your updates on your vehicle. Maybe sometime in 2022 we'll be able to race them. As of right now, my truck is faster than your car, so for right now I can say that my LS is faster than your LS, at least until you finish putting it together. So fellas, have a good night. I will probably see you all next week. Let's see. Thanks for answering the questions, Tyler. That's really why I do all these live streams, because I really want to make sure I'm not leaving anybody behind. Trying to make sure I'll check out the video, Nova. Don't worry. I'm trying to make sure everybody gets caught up. I don't want anybody making mistakes they're gonna regret later, because I've made a ton of mistakes myself when doing a bunch of stuff. And if I could go back and help myself, I would, but I can't. So the best thing I can do is help other people, prevent them from falling into the same traps that I ended up doing. So my Instagram, as you guys know, is always open for messages. I always respond. That's at the Night Wrencher. I don't do a lot of like video updates on there. I kind of just post like my personal stuff, like what I'm doing, what I'm building, etc. But my message, my inbox is always open. If you guys ever have any questions, just send them over my way, and I will answer them. I already talked to some of you guys, so a few more won't hurt anybody. So I'll see you guys all next week. Great to see you.